The focus of this lesson is on various interest problems that we'll be dealing with in this class. We will be dealing with simple interest, compound interest, and compound interest varies based off the number of times it compounds in a year, and then continuous compound. When we talk about simple interest, it's just your simple interest is equivalent to your principal times your interest rate times your number of time in years. Your compound interest is your principal times 1 plus your rate over the number of times you compound in a year raised to the number of times you compound in a year times the number of years. So there's various variables there that you have to take into account. If you are continuously compounding, the formula changes into the principal times Euler's value raised to your rate times the number of years. So keep that in mind. So depending on the wording of the question, you may have to identify which formula you would be using. Now, in the example that I have here, we're going to be using the information they give us to solve all the various types. We will do a simple interest, we'll do a compounding annually and a compounding monthly, as well as a compounding continuously. So we will use that compounding formula twice to do parts B and C. So as far as simple interest goes, the formula again is your simple interest is equal to your principal times your rate times your time. So if you know these three values, then you ultimately have your simple interest. So we'll read the problem. It says, in 1626, Peter de Minuit purchased Manhattan Island from the Native Americans for 60 Dutch guilders, which is about $24. Suppose the $24 was invested in 1626 at a 6% interest rate. How much money would that investment be worth in 2006 if the interest was simple interest? So the principal is the $24. Okay, so I'm just going to label that. The interest rate, they said, was 6%, which we would write as a decimal, so 0.06. So in other words, take the 6 and divide it by 100, you'll get 0.06. And then the time is how much time has passed in years. 2006 minus your 1626 would be 380 years. So those are all your different values. So if you want your simple interest, you just need to take those values and multiply them all together. And then when you do that, the result ends up being $547.20. Now, the question didn't ask how much interest would you have. It said how much money would that investment be worth in 2006. So what is the future amount? So we have the amount of interest we'd make over that time, but we need to add that interest to our principal, which is $24, and then that would give us our future amount, which in this case would be $571.20. So that's simple interest. So over that time, you would make about $550 more. If we want to compound annually, then we are going to use a different formula. We're not going to use the simple interest formula. We'll use that our future amount is equivalent to the principal times 1 plus our rate over the number of times we compound raised to the number of times we compound times the time. So there's one additional variable here, so I want to account for that, and the additional variable here that's different from what we already wrote down, so we already know the principal, we already know the rate, we already know the time, is our n, the number of times we compound in a year, but we're only compounding annually, so that means we're compounding one time in the year, so n is 1. So I'm going to go ahead and rewrite this formula but replace the values now. So the principal is 24, and then 1 plus Our rate is 0.06. Our n is 1. And then raised to the 1 times our t is 380. And then you can simplify this further if you want into 24 times 1.06 raised to the 380th power if you'd like. But basically what that'll give us is, and I'm just going to kind of round this, but 99 billion, and I'll just kind of write it with words. And that's an approximation, that's not exact dollars. So that's significant. If we are compounding monthly, we would expect, since there's more compounding periods, we would expect that value to increase. If we're compounding monthly, then our n is 12. And so we would use the same formula where we take our principal times our 1 plus r over n to the nt. But this time around, we would use the fact that our n is 12. So go ahead and substitute those numbers in. But then our power is significantly larger, so that explains why we would expect this to go up significantly. And when we calculate that, we see that it ends up being 180 billion. So I definitely want to compound more often. Look how significant that is. Almost double, not quite. If we compound continuously, so that means we're just like indefinitely, we're compounding over and over and over and over again. What happens? What does our result approach? We have to use the formula where I say PERT. So principal times your e raised to the RT power. Our principal is 24 again. E is e. And there's the e button on your calculator if you need it. And then 0.06 times 380. If you type this in your calculator, make sure that the e is being raised to the power, not the 24 times the e. And then when we calculate this, we end up getting 191 billion. But again, from the wording you can tell which formula you need to use. If you're compounding a certain amount of time, you need to use our second formula. If you're compounding continuously, you use the third. And then if it's just a simple interest problem, the first. And if you need to, go ahead and read over the information I have written in here on the left. It talks about all the significant information. Your rate should always be in the form of a decimal, and your time should always be in terms of years. So if it's not in years, you may have to convert it to years. So just keep all of those things in mind. But that completes our interest problems.